Good day, cadets and cadets. Here we are again to our subject, Electrotechnology 2, Basic Electronics. Okay, this time we are going to study about thyristors. So far, the series of transistors we were talking last time, no? Uh, Now this time, thyristors. Now, by definition, a thyristor is a four-layered, three-junction semiconductor switching device. So again, there is the keyword here, the switching device. So this is again uh, a function of thyristor. No, it may serve as a switch, but of course, there is also another function of thyristor, which is the amplification. No? Now, the thyristor, just like the transistor, it has also three terminals. But this time, we call it the anode, the cathode, and the gate. So, thyristor is also a unidirectional device, just like the diode, meaning to say, there is only one direction. Okay, so this is the actual piece of thyristor. No? So there's a flat pack, and there is like the circular stud type. No? Now, all of the thyristors, we have the cathode, the anode, and the gate. No? So you can see it in the picture, the exact location of the cathode, the gate, and the anode. Now this is the format of the diode, no? An ordinary diode. We have the anode and we have the cathode. If you notice, the structure of the diode has the P and the N junction. No? So there are two layers here, the P and the N junctions. While in the transistor, it has three layers. It can be an NPN or PNP. So in this example, we have the NPN, which the terminals are collector, the base, and the emitter. So if you notice, this is also the symbol for the transistor. And for the thyristor, so we have already four layers, the P, N, P, N. And the terminals are designated as anode, the gate, and the cathode. So if you notice, anode is still the positive, and the cathode is still the negative. No? And this the symbol here at the right is already similar to diode, but except there is already a terminal here. No? So terminal. Now there are types of thyristors. No? Different types of thyristors. We have the SCR, or the silicon controlled rectifier, and we have also the diac, or what we call the diode alternating current, and the triac, no? Or triode alternating current. No? So these are used for AC actually. No? Itong diac at saka triac, because they carry high voltage. Now the actual components, as you can see here, except for diag, has two terminals. No? The rest, they have three terminals. And the symbol, so this will be the symbol now, simple diode, but there's already a terminal here. But for diac, if you notice, it's just like a diode, but in opposite direction. So, and then the triac, they still have the same as diode, but there is an additional terminal here, which is the gate. Now, let us see the description of each thyristor. For SRC, it is a unidirectional current. So, because if you notice, there is only one arrow here. And then it is triggered by positive pulse at gate. So the thyristor can just function, or can just the current can just flow if you trigger at the gate. So you call it gate triggering. You apply voltage here at the gate, and then the gate here will already like close or open, no? So it will let the current flow here once you apply voltage at the gate, no? So then it is a fast turn of time. So this is much faster compared to the triac, no? And then it has large current ratings. So pwede itong gagamitin usually sa mga power supply. Okay, for the diac, so it has a two-terminal device. So two-terminal device, kaya nga ganito yung forma niyan. And then breakdown voltage cannot be controlled. Unlike in the triac, itong gate mo, pwede mo kasi itong i-control yung voltahe dito, no? While here, you cannot control. So whatever the voltage that is only the limit, iyon na talaga ang voltage niyan. Then it is used as a triggering device for the triac. So ginagamit ito in series with the triac. So before yung triac ma-activate, pinapadaan mo na dito sa diac. So this is also the device wherein you connect it dito sa triac. Now, ang triac naman, it is a bidirectional current. Just like the diac pala, dito sa diac, pwede yung kuryente dadaan dito, pwede yung kuryente dadaan sa kabila. So, terminal 1, pwede rin dito sa kabilang terminal. Kasi yung arrow niya, naka-opposite, no? Dito naman sa triac, aside na bidirectional current siya, meron siyang triggered positive or negative at the gate. So, dito sa gate, pwede siya sa positive, pwede rin siya sa negative, no? Pwede mo ipaano yung positive, pwede yung negative dito sa gate para ma-trigger naman, para pwede dadaan yung voltahe dito. Okay?